Hi everyone. Today we are going to start a new topic, that is matrices. This is one of the important topics which usually from class 10 onwards students are being exposed to, and you will see its applications in your higher studies as well. So matrices not only is used in your mathematics, it is also an important tool in expressing and discussing problems in various fields, like when you're dealing with any electrical circuits, or you are solving any problem in quantum mechanics, in the field of optics. So you have many simulators also. One of the most prominent one is MATLAB, that is used, that is totally based on matrices. So that is something which you will study in your higher courses. So now, what is a matrix or a matrices? First, it should be clear to you. Matrix is the singular form, and matrices is the plural form. This is a plural form. Now, what is a matrix? A matrix is a rectangular representation of elements which are placed in rows and columns so that they can form a rectangle. So suppose I have some elements and I write an example of a matrix as A is equals to A1, A2, A3, A4, A5, A6, A7, A8, and A9. Any representation of objects or elements in the form of rows and columns is known as a matrix. Now, few things which outcast such representation, that is, it will always be enclosed in a square bracket. The elements will be placed in rows. The horizontal ones are the rows and the vertical ones are your columns. And in most of your cases, the matrix is always represented by an uppercase alphabet. A, B, C, anything. Okay, so if I say in this matrix, what is the number of rows and what is the number of columns? So this is your row number 1, this is row number 2, this is row number 3. So it has got 3 rows. And how many columns? First column, second column, third column. So it has got 3 columns. Okay. Now, if I say in this matrix, give me the value of an element which is placed in the second column and in the first row. So second column is this whole thing. This whole thing is your second column. And I say give the element which is placed in second row as well. So I will go through this row. So which is the adjacent or which is the common element which satisfy both the conditions? A5. So A5 is the element which belongs to second row and second column. So if somebody asks you to pick out a particular object from the given matrix, so you can visualize it like this. Or you can also think it as this given matrix A, this is equal to A11, A12, A13. So this is your ID for this particular element. Now second row, first column, second row, second column, second row, third column, third row, third row, first column, third row, second column, third row, third column. So this way you can identify the place value of different elements in a given matrix. Now, whenever you are dealing with any matrix, you will often come across a terminology that is the order of a matrix. Order of a matrix. See, suppose here I am dealing with only one matrix, so I am using the term matrix. When we will be dealing with more than one, then we'll land on to the word matrices. So now, I have a matrix B, and in that, suppose you have the elements like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is no hard and fast rule that if you are dealing with elements in numerical form, that they should be in a sequence. They are always placed in any manner. So now in this matrix, if you see, the number of rows here are 3. 3 rows. And columns, you have first, second, third and fourth. So you have 4 columns. So the order of a matrix will be the number of rows by number of columns. So here it is 3 and columns are 4. So you will say that the above given matrix is of the order of 3 by 4. That is the number of rows by number of columns. And if I say how many total elements the matrix B has, it will be the product of the number of rows and number of columns. So that will be 3 4s are 12. So total number of elements are 12 and the order of the given matrix is 3 by 4. Now there are few different types of matrix which you will come across when you will solve questions based on those, and then you will apply many mathematical operations on those matrices. So let's go through the types of matrix or types of matrices. It is even asked in competitive exams as well. So whatever students who are listening to me, whatever you are studying right now, you should study in such a manner that you don't forget it. Because either you give any public sector exams or some multinational companies, if you are appearing in any sort of exams, the questions from these class onwards, you will always find them. Half of the things are knowledge based and half of the things are application based. Okay, now the first type of matrix you will find is the row matrix. That is the row matrix. This is the type of matrix where you will find elements in the single row. Means the matrix which has only one row and many columns. One row and many columns. So I can put it as A, B, C, D. So here row is 1, columns are 4. Or you can think it as 21, 22, 23, 24, 25. These all belong to your row matrix. So you have a single row, elements are placed in a single row, but columns can be any number. Second type is your just inverse of it, the column matrix. Column matrix. Suppose I have a matrix A and it has elements like 50, 51, 52, 53. So column matrix is such a type of matrix where you have elements placed in a single column but many rows. The rows can be any number of rows and column will be always one only. So column matrix is the matrix which has elements in a single column but with multiple rows. Third type is your square matrix. Now you know the property of a square, all sides are equal. So in square matrix, what will be the condition? The condition will be the number of rows will be equal to the number of columns. If this condition is satisfied, then only that particular matrix will be called as a square matrix. So I have a matrix B and the elements are 1, 2, 3, 4. This is a square matrix. The number of rows are 2, the number of columns are 2. So this is a square matrix. Or you can take a bigger one. You can take 3 columns, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is a square matrix of the order of 3 by 3. This is of 2 by 2. So if you see in both the examples, here number of rows and number of columns both are equal. And number of rows here is 3, number of columns is 3. So square matrix, to satisfy the condition number of rows equals to number of columns, then only a matrix will be called as a square matrix. Next is the rectangular matrix. Rectangular matrix. Now in rectangular matrix, what the condition is, first condition is the number of rows is not equal to number of columns. Very first thing. And second condition will be that the number of rows will always be lesser than the number of columns. Then only the any matrix will be called as a rectangular matrix. So for an instance, I will take a matrix A and in that I will write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So if you see here, you have number of rows as 3 and number of columns are 4. So obviously, both the conditions are getting fulfilled. Number of rows is not equal to number of columns and number of rows is lesser than the number of columns. This is of the order of 3 by 4. Therefore, this type of matrix is called as a rectangular matrix. Okay. Next is you have the zero or null matrix. Zero or null matrix. This is a type of matrix where all the elements are zero. No matter what the order, no matter what it is. All the elements are zero, whether it is a column matrix, it is a row matrix, it is a square matrix. If all the elements are zero, it will be considered as a zero or null matrix. Then one more type of matrix is there, that is the diagonal matrix. So diagonal matrix is the type of matrix in which you have all the diagonal elements as non-zeros and the rest of the elements you will find as 0. So suppose if I remove this and put some values here, 1, 0, 0, 2, 0, 0, 3. So if you can see in this, only diagonal elements are non-zero and the rest of the places are filled with zeros. So diagonal matrix is the type of matrix where you will find values only in the diagonal part of any given matrix. And the last one is your unit or identity matrix. Here what the thing is, in the diagonal you will only have one value. Rest of the places will be filled with zeros. So unit or identity matrix means the diagonal elements are always 1. Means any matrix where you see the diagonal elements have only one filled there and the rest of the places are placed with zeros, then such type of matrix is known as your unit or identity matrix. So this was a introduction to matrices. In the next session, we'll see how to have mathematical operations on a given matrix and few other operations as well. So stay tuned. Thank you.